Today our topic is identify points, lines, and planes. So our central question is, how can I name geometric figures? Point. Point is represented by a dot, and it's named with a letter. Over here we have A next to a dot, so it is point A. And to be more specific, it is a capital letter. Line. A line extends infinitely. It cannot be measured. It is represented by a line with two arrows. If you look, we have a line. There are arrows on the end. It's also named by 2 points on the line, and then you can put the line over it. So you can either spell out the word line AB, or you can put AB and then put a little line symbol on top of it. It can also be named opposite. We can switch around the A and the B. Through any 2 points, there is exactly one line. Collinear points are points on the same line. A plane. Through any 3 points not on the same line, there is exactly one plane. Coplanar points are points on the same plane. You see over here, this parallelogram type shape is a plane. There are 3 points not on the same line, so we can call this either plane M. This M over here doesn't have a point. Or we can name it by 3 of the points, so plane ABC. Practice. Give 2 other names for line PQ. 2. Give 2 other names for plane R. 3. Name 3 points that are collinear on the same line. And name 4 points that are coplanar. Right now, please pause the video, try these on your own, and then resume the video to check in. Answers for number 1. Give 2 other names for line PQ. We have line PQ right here. There's this little letter right there, so we could name it line N. Or we can flip-flop the order and we could do line QP. Give 2 other names for plane R. We have plane R here, so we need 3 points that are not on the same line that are inside the plane. So we could do QVS. They could be in any order. It could be VQS. Or we could do QPV. You could also have QVP. You could have any combination of these 4 points, but only use 3 of them. Name 3 points that are collinear. So 3 points on the same line would be these points right here, T, P, and S. And then name 4 points that are coplanar, all on the same plane. We'd have Q, V, P, and S are all points that are on the same plane. Segment. A line segment AB consists of the end points A and B, and all points on line AB between AB. So it's just saying a line segment is a piece of a line that has 2 endpoints. So it's endpoints A and endpoint B, all the points in the middle. This is named similar to a line where you use 2 letters, but you just draw a line segment above it. You don't put the arrows on it. A segment can be measured. You can find the length of a segment. AB, if you just have the letters with no line on top of it, that means you're talking about the length of segment AB. Ray AB consists of the end point A. So that first letter is the end point, and all the points on line AB that lie on the same side of A as B. So if we look over this image over here, it makes more sense. We have ray AB, where A is your end point, and then the other piece is a line that extends indefinitely. So it's like half of a line and half of a segment put together. You always put the end point first for the letter, and then the second point that is on the side of the arrow. So like over here, end point is B, so B goes first, and then it goes in the direction of A. So we put A after and draw the ray on top. If point C lies on AB between A and B, then ray CA and ray CB are opposite rays. You kind of see it? If C is the middle, you have ray CA going that way, and then you'd have ray CB going that way. They go in opposite directions, so they're opposite rays. And they put together to make a line. Practice. Give another name for segment GH. So we look at segment GH. We can also name it segment HG. Draw that line segment on top. Name all the rays with endpoint J. J is right here, so we'd have JE. Make sure we're putting that endpoint first. JG. JF. And JH. Make sure you're putting the ray on top and always putting that endpoint J first. Which of those rays are opposite rays? Well, the opposite rays would be these two, so JE and JF. And then the other piece, they make that line, so JH and JG. Next little section is use segments and congruent. So our essential question is, how can I determine if two segments are congruent? Postulate or axiom. These are going to be important terms. A rule that is accepted without proof. A rule that is accepted without proof. Write that on your paper. Theorem. A rule that can be proved. So we do not accept it without proof. We must prove it in order to accept that it is true. Segment addition postulate. Postulate means we accept it without proof. If B is between A and C, so if point B, right there, is between point C and A, then AB, that means length of segment AB, right here, this length, plus BC, so the length of segment BC, this length right here, equals the length of AC. So we're saying it equals this entire length here. Just seeing it drawn on the piece of paper makes it look like it's true. That's why it's a postulate. We don't need proof to accept that it's true. We understand the concept. So, also backwards, if AB plus BC equals AC, then we know that B, that point, is between A and C. So in our example down here, we want to find GH. That means we want to know what is the length of segment GH. We want to know what's the length of this segment right here. What is this measurement right here that I'm drawing in blue? So we know FG is 21 plus whatever GH is right here. So whatever GH is going to be equal to the total amount right here, 36. Use our solving equation skills, minus 21 on both sides. We get the length of GH is equal to 15. Last little piece, congruent segments. Congruent means that they are the same. And for segments, it's line segments that have the same length. For line segments that have the same length, we mark them with these tick marks that mean they're congruent. Also means that their lengths are equal. So we'd have segment AB, segment CD. That means AB, that length, is equal to CD. And that the segments are congruent. To write congruent, we use an equal sign with a line above it. With a squiggly line above it. Example, plot these points right here, J, K, L, and M, Determine if JK and LM are congruent. So J is -3, 4. Good practice plotting points. Label that point as J. K is 2, 4. L is 1, 3. And M is 1, -2. We have segment LM right there. Segment JK. JK is 1, 2, 3, 4, 5 segments long. LM is 1, 2, 3, 4, 5 segments long. Since JK is equal to LM, we can say that JK, segment JK, is congruent to segment LM. So yes, they are congruent. That's all the notes I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.